Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, Managing Editor for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on demand. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions. And we'll try to get to as many as we can near the end of today's webinar. Also during today's webinar, we will have 3 polling questions, 1 at the beginning and 2 near the question and answer period. So hopefully we can get everybody engaged. And at the end of today's webinar, we are doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, so let's go ahead and kick off today's webinar, which is managing your full application lifecycle using GitOps. Our speaker today is Victor Parsik, I believe it is, Principal DevOps Architect at CodeFresh. Victor, thank you so much for joining me today. Really appreciate it.
Thank you for having me.
All right, great. So as I said at the top of the hour, we do have some polling questions. The first one I'd actually like to push out now. And so it should be right up on your screen if it's not there yet. The question is, when do you plan to use containers / Kubernetes / serverless? Easy for me to say. You can select one from we do already, we are migrating now, we are planning to migrate, or we have no plans. You can go ahead and make your choice. And I think that this is we're going to see some really interesting responses to this particular question, and I hope that it's actually going to help kind of form your conversation today, Victor. But I will keep this open for a couple more seconds until we get things going, and then we'll take a look at the polling results. Okay.
Let me tell you that those of you answering with no plans are making me depressed.
Well, let's try not to make Victor depressed, shall we? All right, let's go ahead and close the poll and we'll take a look at the results. Looks like the majority of folks actually are doing Kubernetes, containers, and serverless already. So that's always good news, right?
Oh, yeah.
All
those
right.
16% of you, I know where you live.
All right, well, with that in mind, I'm going to go ahead and hide these results, and I'll turn the presenter mode over to you, Victor, and you can go ahead and get started with your presentation.
Cool. Okay, so hey, thank you, welcome, all that stuff. You already heard my name is Victor. I work for CodeFresh. If you don't know what CodeFresh is, go to codefresh.io right away, immediately. So what I will be talking, actually demoing more than talking today, is how to combine, how to inject GitOps principles into full life cycle of our applications, or in other words, how to inject GitOps principles into continuous delivery pipelines. Now, for those of you who don't know, I will explain what those things are very, very briefly. I will not go into details because I'm guessing that you already know. So GitOps is, let me see how to define it. It is acknowledgement that everything we do is defined as code one way or another. And by code, what I mean is something that can be interpreted by machines. It can be Java, it can be Go, it can be YAML. I don't care. If it can be interpreted by machines, it is code. And where do we store code? We store it in a version control. And the only version control that exists today, that makes sense today, is Git. So we call it GitOps. And if everything is defined as code, and if all the code is stored in Git, that means that Git defines completely the desired state of what we want. It is a complete source of truth of our desires. And then on the other hand, we have clusters, which are the actual state. And we need some kind of processes that are making sure that our desires, the desired state stored in Git, is converged into the actual state, so that the reality is always the same or as close as it can get to the desired state. And as I said before, desired state is everything stored in Git. So that's what GitOps is. It is basically those few principles. Then we have continuous delivery, continuous deployment, which is a fully automated process that starts by us making change to Git, making change to the desired state, one way or another, pushing changes to Git. And then everything is fully automated until the very end. And very end depends on whether it is continuous delivery or continuous deployment. If it is continuous delivery, then the end of that full automation is a release or set of binaries releasable to production. The end result is something that we can deploy to production by clicking a button or executing a command without being afraid that bad things will happen, without thinking whether it will explode or not. And if we do continuous deployment, then there is no such button, but every single push to the master branch or main line of code repository ends up being deployed to production. So those two processes are more or less the same. The only difference is that whether at the end of the process there is a button that says deploy me, or it is deployed to production. So full automation or almost full automation. So what I'm going to try to do today is to walk you through a hands-on exercise through the full process. Apply full automation until it is released to production and using GitOps principles. I will have to pick a couple of tools because if it's going to be hands-on, it needs to be done with something and on something. So I will be using Kubernetes today. Now, everything I'm showing you applies equally to any platform, any tool, and so on and so forth. I just picked few, and one of them is Kubernetes. I will be using Kubernetes today. To be more precise, I'm using really works in any Kubernetes. Everything I do works in any Kubernetes flavor. And then we have something that will converge the desired state into actual state. Call it GitOps, call it whatever you want. And today I will be using ArgoCD for that. Ignore the word CD. ArgoCD is not about continuous delivery. It is not doing continuous delivery. It is a horrible name. It is doing deployments. It is making sure that our applications, the actual state in a Kubernetes cluster is the same as the desired state defined in Git. And then I will need to you need to have some continuous delivery pipelines. I will be using CodeFresh for that. Here's the reason. There's the reason. It's awesome. Try it out. Go to codefresh.io if you don't know what CodeFresh is. Don't be embarrassed. And what else do I need? Yes, one more thing. So I will, except to show you what's going on, except to show you what is happening behind the scenes, I will not be accessing my Kubernetes cluster at all. Neither me nor any of the tools outside the cluster will have access to the Kubernetes cluster. Nobody and nothing. Simply because the reason is relatively straightforward. If Git defines at any given moment the desired state of my cluster with every change that might be happening there, then there is no need for me to access Kubernetes cluster. And since I will be using ArgoCD, there is no need for any other tool to access Kubernetes cluster because Argo will be running inside of the cluster and it will be pulling information from Git. So as a result of all that, the only thing I need to do is to make sure that my binaries are built, my container images are created, that tests are executed, and so on and so forth. But neither me nor my pipelines will be interacting with the cluster in any form or way. The only point of interaction between me and the rest of the system and between pipelines and the rest of the system, and between anything else and the rest of the system, is going to be Git. In this case, today GitHub, but it could be something else. So Git is the only interaction point. Whomever needs to find out something, it's in Git. Whomever needs to change something needs to change Git, not a live system in any formal way. Now, with all that out of the way, please keep asking questions. I will answer them all whenever we get to that part. So more questions, the better. I will try to be fast so that I have a lot of time for your questions. Now, let's crack this on and let me start doing a demo. Now, one thing that is important is that I will try to do only the things that every single developer in the world does. So I will show you some tools, but from the process perspective, from the actions that I will be doing, there will be nothing new. You will not see anything you haven't seen before. I will do exactly the same thing that every single developer in the world is doing right now, today. That being said, I am now a developer. Let's see what I would do as a developer and whether there is some magic going behind the scenes. There will be a lot of magic behind the scenes, but I'm right now having a hat of a developer, okay? So what do developers do? What do? I will go to a repository, local copy of a repository of one of my applications. And I will start working on a new feature, right? What do you do when you start working on a new feature? What is the first thing you do when you start working on something new, on a new feature? You create a new branch, my new feature. So I switch to a new branch, and now imagine that I'm spending hours, maybe a full day writing code. I never write code for too long before creating a pull request. I want that feedback as fast as possible. But now imagine that a couple of hours passed and that I made some changes to the code. I'm going to do some changes to the README repo just for the sake of simulating as if I spent hours coding. And now I feel that my feature is ready to go to production. Now, between me thinking that I'm ready and between getting into production, there are a lot of things that needs to be done. But let's start. I'm going to add those changes. I'm going to commit those changes. This is a silly message. And I'm going to push those changes to the newly created branch. So far, you haven't been doing anything that every single one of you is already doing, unless you're a manager. Then you're not coding, probably. Then you should be ashamed. Anyways, next thing I need to do is to create a pull request. I want my colleagues to review the changes that I'm proposing. I want it to be deployed somewhere. I want it to be tested and so on and so forth. And here is the first issue. I want my pull request to be deployed independently of any other pull request from any other person in my company that is doing that. That means that I need to have as many pull requests deployed as there are open pull requests. And when I close that pull request or when I merge it to the master, I want it removed from the cluster because I'm a good person. I don't want to waste more money, more resources than absolutely necessary. So every time I open a pull request, a process needs to be executed that does a bunch of things like build binaries, build container images, run tests, and among other things, deployed in a unique space where it will not collide with others, and that will provide me an environment specific to my pull request. And what else do I want? Yes, and remember, I'm applying GitOps principles, so I don't have access to the cluster. And the tools I'm using don't have access to the cluster. The only thing I or some process can do is push changes to Git saying, hey, this should be running in a cluster. This is the new desired state. Okay, so that out of the way, I'm going to create a new pull request. I like terminals. If you don't like terminals, you need to trust me that you could do it from a UI, from going to GitHub, what's not. Repository is this one. That's a wrong character. Haba. GitOrg. I'm a DevOps toolkit. and it needs a title. Pull request needs a title. I hate titles. And it needs a body. I'm too lazy to type. Okay, so I created a pull request. That pull request is here. I'm going to store, it is the first pull request in this repository. I'm going to store that number in environment variable for later, just in case I need it. Now, let's see what happened when I created the pull request. Let me copy this address. Let's go to the browser. When I created a pull request, you can see here that some checks haven't completed yet. Something is running in the background. Let's see what that something is. I'm going to click details, and this is the pipeline that was executed as a result of me creating a pull request. Now, this is a typical pipeline. If you're using some CD tool, you're already used to pipelines. Half of the things are something that you're already probably doing. I'm cloning the Git repository. I'm building the binaries. This is a simple Hugo application. I'm building the container image. Then I'm going to enrich that image so that information about the commit, about the pull request, all that information is stored in a container image. And I will add any Jira issues that I might have associated with this pull request. Those are the typical things. What is not typical, what you might not be used to, is what is happening in the deployment phase. Now, in your case, in your pipelines, deployments might be doing SSH into a server and then doing something inside of your server. Or it might be executing kubectl apply, or it might be executing Helm something, or whichever method you use to deploy your stuff. But I will not do any of those things, because as I said before, I want Git always to reflect the desired state. I want Git to be source of truth. So what those three on the right side will do is that they will clone a repository that defines my cluster or segment of my cluster. It will make some changes to that repository, and it will push those changes to that repo. And I will show you that repo right away. So this is the repo that defines my, I call it preview environments or pull request environments. And right now, you can see that there is a namespace there, but there is no application defined in this repository. This part of my cluster is empty, nothing is running there. Something should be running because I just created a pull request. And this pipeline will make sure that this Git repository is modified. And I will show you soon what will happen. It is pushing and pushing and pushing. Okay, pipeline finished. And look at the repository. This file was just added. And this file defines that there should be an application in my cluster. That application is defined. Where is it? This is the repository where the definition of application is. This does not define all the things I need for application. It's just a reference saying, hey, go to that repository to find out what is the definition of the application. Inside of that repository, you will find the directory Helm. That's where it is. And by the way, I want you to overwrite some values. I want you to use this image. I want you to use this tag. This is the tag of the image that was built by the pipeline. And I want you to expose this application through this unique address that will, through which this specific application, this specific preview pull request or results of the pull request should be applied. So Git that defines my preview environments was changed, and then as a result of that, I should probably see some changes in a cluster. Let's see what happened inside of the cluster. Kubectl get namespaces. Namespaces are subclusters if you're not very familiar with Kubernetes. This was pre-created. Think of this as being segment of the cluster, a space inside of the cluster dedicated to this pull request. And you can see it by the name, it is unique. PR, the name of the application 1. If I would have 100 pull requests, they would all be deployed in separate namespaces. And if I kubectl -- namespace this one, if I show you what's running there, I should have my application up and running. So it is up and running. Okay, some problems happening there. What's going on? Describe pod. I'm failing live. That's horrible. Why is this not working? Okay. I'm failing live. This is horrible. Something happened that I did not predict. Maybe my image was not pushed to my GitHub repository. I don't know. Or maybe there's something terribly wrong with GitHub. It can be anything. Let me see. Yeah, since looks like that there are problems with GitHub. Why? Building container image. Let me see very quickly. What's wrong? What's wrong? What did I fail to do? Devil's Toolkit 06. Yeah, it was pushed to GitHub, Docker Hub correctly. Okay, we seem to have a problem with Docker Hub. That's bad. Maybe it fixed itself in the meantime. No. Okay. There is a problem with Docker Hub. I'm going to do a quick fix here, and I can show you at the same time how it all works. I'm going to change this to latest because I know that this one works. And then I'm going to commit changes to GitHub, and you will see what will happen. I changed the tag and saying, okay, there was a problem with that tag. It doesn't work. Let's see whether it will work now. Here you see how a new pod was almost immediately created because ArgoCD figured out that there is definitely a problem with Docker Hub. Let's use this one. There is a problem with Docker Hub. This is embarrassing. It's not my fault that Docker Hub is not working. Gonna change it one more time to yet another image. Come on. Okay, this one works. I don't know what's wrong with that repository, something wrong, but the new image should hopefully be running well. Here it is. I even showed you how all you have to do to fix problems is change the definition in Git. That was not what I had planned, but that's what happened. Problems with Docker Hub, who would have known? Probably related with the recent changes that they made to the policies of the world pulling images from Docker Hub. Anyways, it works. Now, where was I? I got disrupted. Now, what should happen if I go to this pull request and say, look, this is a horrible thing. I don't think I can review the changes and say, hey, this is horrible. It failed tests, or I don't like it, or something like that. This will never go to production. I should close this pull request. Now, as you can probably guess, when a pull request is closed, that will trigger yet another pipeline. I will show you here. Here is a new pipeline that will do a few things. And the few things that this pipeline will do is basically very simple. There is no need to build anything. There is no need to run tests when I close pull request. The only thing I want when I close it is to remove the application from my cluster. There is no reason to run it after the pull request is closed or merged. So those 3 steps will go to this repository. It will change the repository by removing the file, and then it will push those changes to Git. And I will show you right away. The file is here. I will refresh the screen. Still there. Still there. Come on. Refresh. Refresh. I'm so impatient. You probably noticed that. And now the file is gone. So the file that says, I want to have this application running in this specific namespace is not anymore in Git. And the result of all that is that if I list the pods in that namespace, there is nothing. The moment the Git repository was changed, ArgoCD figured out that the desired state is different than from the actual state and made changes to my cluster, in this case by removing the application. Similarly, I can go back to pull request, and if you're noticing, the only thing I'm doing is interacting with Git. When I show you commands, it's just to show you what's happening behind the scenes, but from developer perspective, I'm just interacting with Git. I can reopen this pull request. This will run a pipeline, this one that says run a pipeline when a pull request is open, and it will do the same thing as before. When I created a pull request, it will say, hey, oh, so you don't want that pull request after all. You don't want it closed, you want it open. That means that you, among many, many other things, you probably want that application to be running inside of your cluster. So it will run a pipeline that will ultimately, here we are, ultimately, after building a new binaries and new image and what's not, ultimately it will push changes to Git instead of interacting with the cluster directly. ArgoCD will detect those changes and it will redeploy the application to a namespace dedicated to that pull request. Now, let me fast forward a bit and say, imagine that this pipeline finished, pull request is redeployed to a unique namespace. What do we do next as a developer? I would probably say, hey, this looks great. I agree. This is awesome. Let's deploy it to production. Or not that. Let's start the process of deploying it to production. Now, I will assume 2 things here, 2 assumptions which can differ from one case to another. First is that merging a pull request to the master branch or to the mainline is how to explain it? It is expression of the intent to start the process of moving that feature towards production. And the second assumption I will make is that we are doing continuous delivery and not continuous deployment. What that means is that I will assume that you want to create a production-ready release, but you want somebody to approve deployment of that release to production. So I want another pull request. So let me write that comment and let me merge this pull request. Is the pipeline finished? Almost finished, right? Let me merge that pull request now to the master branch. And now 2 things should happen. If we look at the builds, 2 builds should start. One, the same one that was running before when I closed the pull request. That is a pipeline that will remove the temporary preview environment because we don't need it anymore. The pull request was just merged to the master branch. And the second pipeline, this is a more interesting one, that will create a new pull request in a repository that defines this time production, and that will allow somebody to review those changes and approve those changes to be running in production. So let's look at this pipeline. This is not doing much here. it is cloning a repository. This time it is cloning the repository that defines production, not previews anymore. It is, this is actually cloning. It is modifying that definitions in the production environment. I will show you those modifications in a second. And then it will push those changes to the branch and create a pull request. We're almost there. While waiting for that, let me open my repository that defines production. Here it is. This is the branch that was created. Still not there. Need to wait for a second. I will have a sip of beverage. It's so amazing how time's changing. Like 10 years ago, 15 years ago, I would consider myself lucky if things moved towards production within less than a week. Anything less than a month was lucky 15 years ago. Now, if I need to wait more than half a minute, I get impatient. Anyways, if I go to my production repository, this is the repository that defines everything running in production. And let me show you actually what is running in production. Right now, those two applications are running in production. One is DevOps Paradox, one is DevOps Toolkit. Those were the applications that were running in production long before I started this webinar. And now the pipeline created this pull request. And let's take a look at what is in this. Imagine that I'm a person who approves deployments to production. I can look at what changed. Those things changed, excellent. Most of those changes are cosmetic, not important. The only one that matters is this line here. It says, hey, before you were running the latest tag in production. You should be publicly ashamed and not work in this industry anymore because you should be specific. The new suggested change is to run this specific tag in production. So somebody suggested that this tag should be deployed to production. And let's say that I'm a person who has godlike permissions, and I'm in this pull request. I can say, this is awesome. It should indeed be deployed to production. And I am a godlike figure who has the permissions to merge PRs in this repo, so I will approve this one. And what do? I will merge this pull request. And before I do that, I need to tell you that my ArgoCD is configured to apply to production cluster only what is in the main line of this repository. Whatever is in branches doesn't count. The moment I merge this pull request, that will be the change of the desired state of production. Now, let's see what is going on in production. kubectl-n production get pods. I have, those are the two old versions running in production. And this is the one, the image that I already explained, something going on with GitHub. I'm not sure what, Docker Hub, sorry. I'm not sure what, so my images are not working today. I'm gonna fix that soon, actually. I'm going to do a workaround very quickly. And how I'm gonna do it? By changing the definition to, I know that this one works for sure, and 2.9.9 probably exists if my memory serves me. It was built earlier. Let's see now. Watch kubectl-n production get pods. Wrong command. Pods. And come on here. Maybe that tag does not exist. Let me see. Hub, Docker. This is debugging live. Doesn't happen often. Let me see one of the tags, 2910, DevOps Toolkit series, 2910. There is something terribly wrong with Docker Hub. Oh my God. This should work. This was DevOps Toolkit series with Farsi. Why did Docker Hub have to start failing just now? Let's see. I think that this tag should work. Yeah, here we go. It does. Or maybe the previous one worked as well. Anyways, you can see here that the new release is running for 32 seconds because I made changes to the master branch of my repo. And that's about it. I was fast. I was extremely fast. We have 25 minutes for discussion, for your questions, anything you want to ask, do, and so on and so forth. So shoot.
Absolutely. All right, guys, plenty of time for questions here. I'm actually going to go ahead and take presenter status back from you, Victor, but while I am doing that, I do want to let the audience know that there's plenty of time for questions. So if you do have a question, please go ahead and use your GoToWebinar control panel and submit your questions. I put a very nice image up on the screen that maybe Victor can talk about a little bit while we're waiting for a couple questions to come in.
Yes, this is so. While waiting for questions, I work for CodeFresh. We were in the before mostly focused on CD continuous delivery pipelines, everything pipeline related. For a while now, we've been transitioning, not transitioning, but expanding greatly to become probably the best Kubernetes focused CD solution. And next week, we are having a huge launch. That's why I cannot show you some of the things because it's coming next week, where we will announce our integrations with some of the very popular tools related to GitOps, specifically with ArgoCD. So us and ArgoCD becoming like a married couple and providing a lot of additional values on top of it.
Excellent, excellent, excellent. Well, so we have gotten a lot of questions in so far, but before we do that, I actually do have two polling questions I want to push out to the audience real quick, and then we'll dive right on into the questions. Here's the first one, should be up on your screen now. Did this webinar meet expectations? Victor did a great job of tap dancing there during the time when the GitHub did not want to work for him.
To improve, I will be dancing. You cannot see me, right? Okay.
Not right now, but you did make me laugh a lot.
You need to imagine me dancing out of joy because you're going to say that this was awesome.
Excellent, excellent. Well, yes, you can choose from, did this webinar meet expectations? You can choose from, yes, that was awesome. Yes, this is what I expected. Maybe you know Victor already and that is what you expected, or not exactly. You can go ahead and make your choice. We'll give you guys a couple seconds, then we'll close this out, and then we'll put the other one up on the screen, and then we'll dive right on into the questions. So, okay, looks like we have a pretty good amount of responses. So I'm going to close this one out, and let's take a look at the next polling question, which is, do you want to try CodeFresh? You can choose from yes, let's schedule a one-to-one to help get me started, or help me get started. Yes, I will try it on my own. No, not right now, or I already use CodeFresh. So go ahead again and make your choice, and I will give folks another a few seconds to go ahead and make your choice. As I said before, we have a lot of questions in the question and answer tab already, but plenty of time for question and answer. So please go ahead and use your GoToWebinar control panel if you have a question for Victor, and we'll try to get to as many as we can near the during this question and answer period. Okay, I'm going to go ahead and close out this poll, and Victor, let's get into questions now. All right.
Okay.
Here's the first one. Okay, Victor's experience with his cloud development servers becoming inaccessible is why I still cautiously do only local program preparation. Why isn't availability of environments seen as a bigger problem for cloud-based DevOps? That's a good one. P.S. I've seen many cloud demos disrupted by environments being inaccessible. Is this just me?
So on one hand, we need to be prepared to react when things go wrong, and things go wrong in cloud, they go wrong in on-prem, they go wrong on our laptops. The third person that is supposed to be in this webinar is not here right now because I suspect that she is restarting her laptop. Karin, I'm talking about you. So things are failing locally, things are failing on-prem, things are failing on cloud. Whether it's failing more often on cloud than somewhere else, that's to be debated. What matters much more from my perspective is that we are ready for those things and we know how to react when bad things happen. Now, as for the demo itself and many others, to be honest, I try to squeeze a lot of things in a very short period of time. I would go a bit slower and be more cautious if this would be the real environment. I wouldn't start developing new feature and have it running in production in 25-30 minutes as much as it took me right now. So I would have additional measures that are not part of this demo, making sure there would be a staging environment maybe, or actually when I would deploy to the preview environment and things were failing there, I would spend time to figure out why it's failing there before going to production. And I skipped that part because I wanted to show you a quick demo, right? So blame me trying to squeeze too much things into too short of a time.
All right, all right. Well, I don't think anybody's laying blame anywhere, but it's certainly an interesting
My
question.
My girlfriend is blaming me a lot, so why not you?
Okay. All right. Next question. Let's move ahead. What is a command to add code to a repository for the first time?
So if I can share my screen again.
Sure.
What I did, what I set up here is.
Hold on, let me make
am I sharing now?
No, sure. Not yet. Okay, now you are.
Okay, cool. So if I go to the repo of my application, the one I was showing you earlier, it's actually very simple what I did. You know, everything is simple when you do it after the first time. So this is the repo of my application. And I'm having here two files, preview YAML and production YAML. So in this context, I'm assuming that the pipeline shouldn't care how to create a preview environment. It shouldn't care how to deploy to production. Instead, I'm using naming convention and saying, hey, every single repository of every single application has production YAML and staging YAML file. And then this is a production YAML that is templated, so a few things will be replaced at that runtime. So what my pipeline did is it did kind of without really much thinking. It when it cloned this repository and it built a binary and it built container images, so on and so forth, it copied this file and then it made few changes like the image tag and it pushed it to the repository that defines my preview environments. And same thing with production. So the assumption here is that every repository of every application has files, preview YAML and production YAML that define the reference to the repository of the application itself and which values should be overwritten and how. And then the pipeline is a simply copy and git push type of stuff. I'm not sure whether that answers your question. If it doesn't, ask it again, and I'll be more precise.
Excellent. Okay. Next question. How far does CodeFresh pipelines differ from GitHub Actions? Theoretically, I could build it all directly in GitHub.
Yes. Now, I have a rule, and I will be honest here. I work for let's say that CodeFresh is a competitor of GitHub Actions. And I don't want to say GitHub Actions is horrible. I don't want to say GitHub Actions is great. I prefer not to compare competitors because it might be interpreted in a wrong way. So ask me anything except to compare with the competitor. That's the rule.
All right. Next question then, let's go ahead and move on. Is the GitOps approach applicable to deployment destinations other than Kubernetes?
Yes, yes. As long as everything is defined as code, and today we have no problem to define everything as code, then yes. So if you, the real rule is that you push some changes to Git, you have a process that applies those changes to the live system. Now, if you're using Terraform to create your clusters, doesn't matter whether it's Kubernetes or no, then your Terraform definitions are pushed to Git, and then you have a process that applies those changes and potentially monitors when there is a drift between the desired state and actual state. If you deploy it directly to a virtual machine by copying a binary, then still you store the information of which version of the binary should be in Git, and then you have a process that applies those changes. So yes, most of the thing is that most of the advancements today are happening around Kubernetes because it's a hot thing. But on a principle level, yes, GitOps applies to anything, even to the mainframe if you have it.
All right, great. We have probably, well, about 10 more minutes for questions, guys. So if you have one, go ahead and submit it via the questions tab. Next question here, what is the recommended structure of the GitOps repo when you have multiple environments and apps?
That depends really on preference. I can tell you my personal preference. I prefer to have one repo per environment. So one repo for production, one repo for pull request based environments, one repo for staging, and so on and so forth. Because my logic is that master branch is always what really matters. Everything else is temporary. I don't like the idea of using branches to define different repositories, especially since merging branches in the context of environments does not really work. Now it could also be monorepo, and I have quite a few cases like that where there is a single repo and then directories, staging, production, this and that for each environment. That's just as good, especially in our case, since our model for pipelines is really, rather instead of having one huge pipeline, to have distributed pipelines, so many pipelines depending on the context. And in this case, and this is really one of the things that is lacking, I think, in many tools, but in our case, we have just as good or even better support for monorepo than whatever is the alternative to monorepo. So either directories in one repo or one repo per environment. That would be my recommendation.
Excellent. Excellent. Okay. Next question. What tools are you using for functional performance and security tests?
I don't have a strong preference, to be honest. And I spent a huge chunk of my career directly in testing, but lately I've been a bit out of that. So maybe last couple of years I'm not that following it that closely anymore. So I would be afraid to answer that and sound like somebody who lives in a previous decade. I'm mostly focused now on Go, and in Go, almost everything you really need is a part of the language itself, which is extremely simple. I'm trying to performance tests. I'm just writing them myself as a pure Go code, but that might not be a good recommendation for everybody, especially if you're not using Go. So I might not be the best person to answer it.
Okay, fair enough. Okay, next question. What is the relation between CodeFresh and ArgoCD?
Great question. So we spent a lot of time evaluating. So first rule is that we do not want to reinvent the wheel. We want to build and provide to our users unique and additional value. instead of reinventing what exists. So a while ago, we really got on a train and decided that GitOps is likely the best way to manage everything. And then we started evaluating many different tools and came to our conclusion that, and I'm talking about open source tools now, right now, that ArgoCD is the most promising project right now for GitOps-like deployments. So since then, we've been working on integrations between CodeFresh and ArgoCD and providing a lot of additional features and also contributing a lot to the project itself. So the relation is we are contributing to ArgoCD project and we are integrating ArgoCD with CodeFresh and all the other functionalities and building additional features on top. You need to stay tuned. Next week, starting Monday, there will be a huge announcement. You need to go to codefresh.io and you will see. I cannot give details right now, but next week, starting Monday, you will hear a lot about it.
All right. So we have about 9 minutes left in today's webinar. So I think we have time for one more question, then we'll go ahead and close it out. Here we go. How is CodeFresh investing in GitOps?
So mostly through actually on different levels, let's say. One would be contributions to open source projects. Another would be building unique features related to GitOps. And the third one is that I think that we are still early stages as industry in defining and adopting GitOps. So we are putting a lot of effort actually defining best practices and clarifying the ideas behind the whole GitOps movement, and trying. And the thing that I think that we are missing the most is patterns. We are trying to define patterns instead of letting people spend days, weeks, months, whatever, trying to figure out what is a good way. So defining patterns like the one I showed you about preview environments right now, and many others that people can just, go through patterns and say, hey, this applies to me, this doesn't. I'm going to use this one because somebody already thought about it from the process perspective, not only tooling.
Okay. All right. Great. Well, that is, we have about 8 minutes to the top of the hour, but that is pretty much all the questions we have. So we're going to go ahead and close out the question and answer period. I do want to thank everybody who did submit questions. We had a lot of great ones, and I really, really enjoyed them. But I do want to quickly remind the audience that today's event has been recorded. So if you missed any or all of it, or if you just want to watch it again, you'll have the opportunity to do so. Following today's webinar, we will be sending out a link that contains a link to, hold on, let me start again. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the devops.com website. So you can always go look for it there. Just go to devops.com/webinars, look in the on demand section, and it should be right there waiting for you. Okay. At the top of the hour, I did note that we would be doing a drawing for 4 $25 Amazon gift cards. So without further ado, let's go ahead and do that. Drum roll, please. Our first winner today is Joel H. Congratulations, Joel. Our second winner today is Elena T. Congratulations, Elena. Third winner today is Douglas S. Congratulations, Douglas. And our fourth and final winner today is JT. Congratulations, Jay. Congratulations to all 4 of you. We'll be following up with you by email to get your Amazon gift card over to you. So please check your inbox. If you don't see something in your inbox, please check your spam folder. Hopefully it won't be there, but Victor, thank you as always for such a great webinar. Good stuff. And I'm actually going to put up on the screen real quick I know you guys have a quick call to action slide you want me to show. So let me see if I can get to that for you. There we go. Okay, so folks want to take a look at it for themselves. There's a free count information right there at codefresh.io. So Victor, I don't know if you have any final parting words regarding that.
No, just check it out. And if you have any questions, literally, a lot of my work is around helping people, communities, individuals, what's not. So just contact me, and if you have any questions or any doubts or anything, and I'll get back to you. I promise. You can find me Twitter, LinkedIn. Just Google my name. You'll find me for sure.
Excellent, excellent, excellent. Well, thanks again for such a great presentation. Hiccups and all, which I guess that's all part of life, right? So you're going to have to expect that something's going to break along the way. But thank you again for such a great presentation. I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody. Have a great weekend, and please, whatever you do, stay safe.